I have opened the memory data for activity 2 for this week, and I would encourage you to read the description of the experiment. So the main comparison that we are given in the description was between the memory processing for older and younger participants. And again, that's two groups. So if you wanted to do a very simple test for the two independent groups, you could use the independent t-test from last week, with the main outcome of interest here being the number of words recalled. What we're going to have a look at is the process that they used for remembering words. And for any study, I'd encourage you to read through exactly what they're doing, and just to help you think about what the data is telling you, think about what you would expect to see first. So in this case, one of the techniques was counting the number of letters in a word to help you remember it. And I read that and I was just like bemused. I thought, oh my goodness, how on earth would that help you remember anything? And so I would not expect a high result, really, like people remembering a lot of words from that process. But I'm quite familiar with this idea of the imagery technique for remembering words. So I might have expected that one to be higher. So let's go through the process of how we look at this data. And you'll see that I've got the data written, how it's given to us through the website with the words, and I've also coded it into numbers. Most of the stuff SPSS is fine if you've written the variables in words. I think it's possible for the one-way ANOVA that it will require a coded variable. Having said that, now that I'm in the later version, maybe it's fine with it. So we'll see what happens there. So our outcome here is the number of words recalled, and the maximum I think was 27 from memory. And we've got these different memory techniques that we're comparing. And so that's our outcome is continuous. We've got two or more independent groups. We're going to assume that the observations are independent of each other, and then we'll move on to assumptions 4, 5, and 6. So number 4 is that there are no extreme outliers. So let's have a look at a box plot. So the outcome will go on the y-axis because the box plots are going up and down. Level of processing will go on the x-axis for our groups. And we can see here that we have two outliers. These are not too extreme, and actually I think they'd probably balance each other out. So that one's going to pull the mean up a little bit, and this one's going to pull the mean down a little bit. So I don't think this will have too much of an impact on the mean. It might increase the variance for this group a bit, but the analysis of variance is actually fairly robust. I don't think it would be severe enough that it will affect the outcome of the test. What is interesting is that what we can see already is that for, let's say, for these two, imagery and intentional, so imagery was the one that I thought would work well just because it seems like a reasonable memory technique. We've got a reasonable amount of variation here, so perhaps it is helping people remember words, but it's maybe not having the same effect on everyone. And then in the counting and rhyming groups, it's interesting that rhyming doesn't do very well, but anyway, these are much more compact, so it seems to be, I would say, equally bad for everyone in remembering words. So it looks already that we might have a difference in the variation between the groups, which is the assumption number 6, so we'll get to that in a bit. But you can often see that when you're looking at the box plot. So assumption number 5, that will be the approximately normal for each group. So let's have a look at the histogram. Words recalled, display the normal curve, level of processing. Just pause on that if you need that. Okay. So this one looks fine. This one kind of looks okay. Only 20 in each group, so we're not a massive sample size, so it's unlikely you'd get anything looking perfectly normal. These ones here are interesting. They're probably actually a little bit too flattened out to be called completely normal. And this is reflecting that we've got a lot more variation in these 3 groups than we do in these 2. So in this case, I'm actually not too concerned about the normality. I'd be more concerned about the homogeneity of variances assumptions, because I don't think we're going to meet that. So given that I'm not too worried about the outliers and I'm not worried about the normality, we'll go ahead and run the analysis of variance, but we will tick that extra box to get the test of variances, and we'll also get an alternative or adjusted analysis for the variances not being equal. And I'm just going through the Laird guide for consistency, and they recommend the Welch test if the variances are not equal. So let's go through. I don't know if you can hear the beeping through the recording. That's my washing machine's just finished. I'll hang that out in a minute. Okay, one-way ANOVA. So words recalled. And you see, we're only seeing our outcome and the two coded levels. We're not seeing the groups written as words. So that means if you want to use analysis of variance, you're going to have to code your levels. And level of processing. And under options, we're going to tick our homogeneity of variance test. And then Welch is an alternate version if your variances are not equal. Continue. Okay. So if you're on a previous version of SPSS, you probably don't have all of these options. You'll just get one Levene's test for the means. So the null hypothesis is that there is no difference in the variation. We've got very strong evidence against that, and so we will assume the variances are not equal. So that would mean we use this alternate version of the test. When you're doing the independent t-test, it does this Levene's test for you automatically, and it also gives you two versions of the test automatically. So for ANOVA, you've got to tick a couple of extra boxes. Having said that, if we have a look at the p-value for the analysis of variance test, you can see that they're actually both the same. And as I said before, ANOVA is considered to be quite a robust technique. It holds up pretty well, even if the assumptions are not completely met. And if you go on to do more advanced statistics, you might look at how you investigate whether or not it's working under any particular circumstance. You can do some kind of sensitivity analysis on it. So the null hypothesis for analysis of variance is that the mean number of words recalled is the same for any memory technique used. We've got very strong evidence against this hypothesis based on our sample data. So we would conclude that there is a difference in the means. Now, the interesting thing here is if we were using the t-test and we only had two groups and we found that the means were different, we would know that they were different from each other. But for analysis of variance where we've got 5 groups, it doesn't tell us which mean is different. It just tells us that at least one of them is. So we have to do a little bit more investigation, and this is where the post hoc tests or the multiple comparisons comes in. Before we have a look at this extra step, let's just do a graph of the means and confidence intervals so we know what we're looking for. Now, if you've got your box plot here, you can go to bar and drag your error bar chart on top, and hopefully you'll see your confidence intervals have been selected over the side here. So what do we see? So it looks like there's probably no difference between imagery and intentional, probably no difference between counting and rhyming. So these two look equally good. These two look equally bad. Now this one is interesting. It looks better than counting and rhyming, but is there any difference between this one and these two? And that's a little bit difficult to read off the graph. So we definitely need to do the post hoc comparisons, and obviously you would do them anyway, but it's helpful sometimes to look at the graph first to help interpret them. So we'll go back to one-way ANOVA, and we were in the options before. We probably don't need those anymore. We want to go into post hoc. Post hoc just means anything that's done after the event. There's a lot of options here. In practical terms, you'll usually get similar results no matter which post hoc test you choose. What you'll see written in papers, commonly I see Tukey's and Bonferroni, sometimes a couple of others. We're just going to stick with Tukey's for this course. So that one there, continue, and OK. So this was our ANOVA output that we saw before, and now we're going to have a look at the multiple comparisons. And we've got 2 versions of the output. I'm going to look at this smaller version first. Grab my pointer again. So, my poor arm getting dislocated. Hold on, maybe I can walk to the side a bit more. That's okay. Sorry. Puppets are so much fun. All right, words recalled. So what does this do? What it does is it puts the groups in the same column if they are similar to each other. So if there is no difference statistically between these two groups, they appear in the same column. So we have statistically there is no difference between the counting and rhyming. We had about 7 words recalled on average for each, so they come in the same group. Now the other 3 are all appearing together. So what we can see is that, and we could see it on the graph, that there really didn't look to be any difference between the imagery and intentional, but we weren't sure about the adjective. That was the one that was a bit lower. But here we're saying that we don't have enough evidence yet to say that adjective is worse than these 2. We're going to consider these 3 to be equally good, bearing in mind that it's only a sample size of 20 in each group. So perhaps if you were really keen on looking at this difference, you would design a bigger study to look at what the difference is. But as far as this study goes, we don't have enough evidence to say that these techniques are different from each other. The other option that you have for looking at this output is the pairwise comparisons. And this just compares every possible pair of groups. So if we have a look at the graph, hopefully you can see my mouse, so it will compare, is adjective different from counting, is adjective different from imagery, is adjective different from intentional, is adjective different from rhyming. Then, is counting different from adjective, is counting different from imagery, is counting different from intentional, is counting different from rhyming, and we go on. And you can see that that's quite a long process. Hence, this table is quite big. So, let's have a look. The null hypothesis in every case is that they're the same, that there's no difference between them. So is adjective different from counting? Yes, we've got very strong evidence against that. Is adjective different from imagery? Nope. Is adjective different from intentional? Nope. Is adjective different from rhyming? Yep. And so you can see you go through every single pair, and by the time you get about halfway down, look, we've got imagery and adjective. We've already seen that because we saw adjective and imagery. So you should get the same p-value here, the 0.135, as you saw up there. So although it's a great big table, essentially once you get halfway through, you've already looked at every possible combination of variables, and so you will have already known if the difference is significant over here. So you can use either of these. You can have a look at both. Hopefully they give you the same result. This one's probably a little bit quicker to look at, but sometimes it's helpful to look at every single pair. And as always, if I was showing the results, I'd put in the means with the confidence intervals to illustrate where the differences were. And when you're reading these in papers, which you might see in one of the example papers, where you see little letters representing differences in ANOVA, they're referring to these pairwise comparisons. And so that will turn up when we're reading the literature.